welcome to week 8. We've got 3 weeks left, weeks 8, 9, and 10. It leaks over a little bit into week 11, but we're not really going to do much with that. I have posted the final project. I will modify that a little bit because right now I think for the GMRes methods, or really maybe for any of them, I'm asking you in those methods to solve the system using Givens rotations, or to constantly update the Hessenberg matrix using Givens rotations. That is an important thing to be able to do, but not really one of the things that I want to focus on in this class. And the reason is because the parts of these algorithms, these Krylov algorithms that take the most amount of time, are the orthogonalization process. Because if you think about what's happening there, you're doing very large matrix vector multiplications, and it's no longer sparse. So that is really where the matrix is no longer sparse because you're dealing with the V matrix, not the A matrix. And so this is where I want to sort of show how we can reduce the number of steps and also reduce the number of not only reduce the number of steps, but reduce the work that we're doing in each step. And there's several ways that we can do that. This week, we're basically going to look at how we can reduce the number of things we do in each step. We're also going to look in later weeks at preconditioning, which is going to decrease the number of steps that we do. But this week, we're going to look at a couple of methods. The incomplete orthogonalization method, which, as you might suspect from its name, even if you haven't read it in the book, is like the full orthogonalization method, but incomplete. And we'll see more about that in the videos. And the other thing that we're going to look at is start looking at methods that require that A be symmetric. So if you remember in the FOM method, this is the projection method where the Krylov space and the the projection space K and the orthogonal space L are both the Krylov space. For this to really have a solid geometric interpretation, A needs to be symmetric. And as it turns out, if A is symmetric, a lot of things simplify. And we're going to talk about exactly what the implications of that are if A is symmetric. And you'll experiment with some of these things in the program, in the homework assignment that's going to be due next week. Okay, that's it for this week's introduction video.